Hello, I'm Khaing and this is my video for Unit 3 mid-unit assignment. So for the first question of number 1, describe what happened the domain and range of a logarithmic function under the vertical reflection. Support your explanation with diagram. So here is the graph of a logarithmic function of the equation f of x equal to log x, and this is the 5 key point of the logarithmic function. When x equal to 1 by 4, y equal to minus 0.6, and when x equal to 1 by 2, y equal to minus 0.3, when x equal to 1, y equal to 0, when x equal to 2, y equal to 0.3, and when x equal to 4, y equal to 0.6. The function of the f of x equal to log x is the parent function, and the domain is x belong to R such that x greater than 0, and the range is y belong to R. Vertical reflection on x-axis, and so a equal to minus 1, g of x equal to minus log x. Here is the function of g of x equal to minus log x, and the domain is x belong to R such that x greater than 0, and the range is y belong to R. Since we can see that in these two graphs, f of x equal to log x is an increasing, and g of x equal to minus log x is a decreasing. So in these two graphs, the domain and range are not changed, it remains the same. So this for number 1. For number 2 is, describe what happened the domain and range of a logarithmic function under both a horizontal and vertical translation. Support your explanation with diagram. So f of x equal to log x is the parent function of the graph, and the graph is the logarithmic function f of x equal to log x. And the domain is x belong to R such that x greater than 0, and the range is y belong to R. Now we can become to transform horizontal translation and vertical translation. So the general function of the equation is y equal to log x minus d plus c. So we using d equal to minus 2 and c equal to minus 3. This is the graph of g of x equal to log x plus 2 minus 3. And the domain is x belong to R such that x greater than minus 2, and the range is y belong to R. And in the graph, we can see that we move horizontal translation 2 unit and vertical translation 3 unit down. In the function of f of x and g of x, the domain is changes and the range does not change. So the ranges remain the same. It is for number 2 and for number 3. Graph the function of f of x equal to 1 by 2 log x minus 4. So we'll draw the graph of the function of the given function of f of x equal to 1 by 2 log x minus 4. Here is the graph of the given function. So for f of x equal to 1 by 2 log x minus 4, the domain is x belong to R such that a greater than 0, and the range is y belong to R. So it's for number A, and for number A, graph the line y equal to x on the same grid. So here is the line of y equal to x line. And for number B, graph the inverse function of f of x by reflecting f of x in the line y equal to x. So we are going to reflect this graph and across the line y equal to x line, and so here is the f inverse of x graph. So this is the f inverse of x graph. And for number C, determine the domain range and the equation of the asymptote of f inverse of x. So for f inverse of x, the domain is x belong to R and the range is y belong to R such that y greater than 0. The asymptote at y equal to 0, we can see in the graph. The asymptote line is y equal to 0. So we can see in the function of the domain and range in the two graph of the domain and range, the domain for f for x is become the range of the f inverse for x, and the range of f for x is become to the domain of f inverse of x. For number D, determine an equation for f inverse of x. So we were using the given equation of f for x equal to 1 by 2 log x minus 4. So we will let y equal to f inverse of x. F inverse is moved to the other side, so f for y equal to x. And we will substitute y in the equation of f for x, so 1 by 2 log y minus 4 equal to x, and minus 4 is moved to the other side, so 1 by 2 log y equal to x plus 4. 1 by 2 is moved to the other side, so log y equal to 2x plus 8. And log is moved to the other side, so y equal to 10 power 2x plus 8. And y equal to 10 power, we will get the 2, so 2 into x plus 4. So y equal to f inverse of x and f inverse of x equal to y is the same, so f inverse of x equal to 10 power 2 into x plus 4. So the equation for f inverse of x is 10 power 2 into x plus 4. This is my unit 3 mid-unit assignment, so thank you for watching.